All right, so in this lesson, we're looking at the idea of resultant vectors and finding exactly what the resultant vector is. Now, in the last video, we talked about how you find, using a tail-tip method, where the resultant would be. So, resultant vector, we said, like, if these are our two vectors here, you could go and take this one, move it tail-tip, and then you would be able to get the resultant vector. This would be your resultant right here. So you have your two different vectors. The issue being, though, is we want to know what exactly this magnitude of that vector is and in what direction it is. We can approximate it. We can say, well, obviously, with both original vectors going in the left direction, it's going to be even further in our left direction. And that's very not exactly great terminology to use, left, right, up, down, but we could at least say we know for a fact, just based off of our drawing here, we should be going somewhere in quadrant 2, approximately midway through quadrant 2, so about 135 degrees. The issue is we want to get that to be a precise measurement, and that's what we're going to look at here today. Basically, what it is going to boil down to is each vector always has two different components to it. This blue vector that's going really up high and not much to the left, it has a y value and it has an x value to its vector. We call those component vectors, where we have an x value and a y value, or I hope if I say that correctly, it would have a y value obviously going up and down and the x value going left and right. Those are we call them component vectors. And same thing with this one. Not much of a y value, if any, for its component, almost entirely in the x direction. But if you break down every vector into an x and y component, you can find precisely what your values are going to be. Okay? So, for example, if we have a person that's pushing a box with a force of 100 newtons and another one pushing it to the right at 77 newtons, what is the resultant force? It helps to draw a picture to look at it. So here's your box. It says one person is pushing up on the box, so that means that the force is going upwards with 100 newtons, and then another person is pushing it to the right, so we're going to the right at 77 newtons. Okay, so 100 newtons, 77 newtons. Again, with a vector, if we want to find the resultant force, again, resultant, any vector is going to need a magnitude and a direction. To find magnitude is essentially, obviously, the power. It's the total amount. What we said in the last video, to find the magnitude, all we're going to do is essentially find a distance. So if we want to look at it another way, if we were to go and tail tip this vector, here's the 1, and then if I move this vector right on top of it, I'm going to get a resultant. It's going to be, if I draw the other one, the resultant would be somewhere in quadrant 1. So I have an x component and a y component. The x component, we can see from the picture, is 77 newtons. The y component is going to be 100 newtons. So your resultant is just going to be the square root of those values when you add them together, just like Pythagorean theorem, a squared plus b squared equals c squared, and you'll get a resultant when you plug those in of 126.2 or so newtons. Now, to find direction, this is where it's key to know what quadrant you are in. This is in quadrant 1. The way we're going to find direction, it's all based upon this angle in the middle. And we're going to get right back to reference angles again. Told you they never go away, and they don't. What I can do is with this angle, and I know these two values, x and y, well, that trig function would be tangent. I can find tangent of my angle, it equals y divided by x. Well, that means if I plug in those values, I get tangent equaling 100 for y and 77 for x. If I take the inverse tangent of both sides, I get myself an angle 52.4 degrees, and that's how my answer is. And this is how I write my answer. It is a specific value, a magnitude, at a certain angle. Okay? Now, just to be careful, if you had plugged this into a calculator, 54 degrees, yes, is an answer. However, it is also possible, like we said before, in what other quadrant is tangent a positive value? Because 100 divided by 77 is positive. That could also be quadrant 3. So based off of just your angles and your drawing of the picture is how you know that your answer had to be quadrant 1 instead of quadrant 3. And you'll see in the next example another way that we can combat that and make sure that we have the right answer. Okay, well that's it for this video. We'll see a little bit more complex videos, complex problems in the next video, because in this one we were moving just straight up and down, or just straight left and right. Well, what if I was lifting at an angle this way, or I was pushing not straight up and down, but with a little bit of an angle that way? So that's a little bit slightly different, but it still deals with finding x and y, and you'll see that in our next video.